Okay, YouTube, in our last couple of videos, we've looked at the basic shapes of the graphs of sine of x and cosine of x. In this video, what we're going to do is kind of put all of this information together about the graphs of y equals sine x or y equals cosine x into a nifty little method that we call the framing method that'll allow us to graph, I guess, sine and cosine functions or trig functions in general very procedurally. And so we're going to start with this. The fact of the matter is, with our sine and cosine graphs, what we see is that every single sine and cosine graph, if I were to sketch on top of this here, has a basic shape, and we could split it up into 5 critical values essentially. And so with respect to these 5 critical values, we see that a sine function, which normally starts on the x-axis at 0 here, goes up to its maximum, comes back down to 0 again, goes down to its minimum, comes back up to 0. We see it having a basic shape like this, but we see that there are 5 critical values on this particular trig function, and they fit conveniently into what we call a frame. So this frame, with respect to the frame, remember that with respect to the graph, we refer to the amplitude of the graph as this amount of distance that we deviate above or below the center line. And so that amplitude, you can see here, is really just reflected in the height of the frame. So from our beginning point here, we're going to say we go up or down so far to get the top and bottom of our frame. Now, with respect to what else we see in this frame, we can see that this frame is split in half this way, like we've talked about. We go above and below by the amplitude, but also split in half, and those halves split in half this way, so split into fourths. And with respect to our frame, we can see that that's really just splitting it up into our 5 critical values here, one at the very beginning of the frame, one at the 1/4 of its period mark, one at the half period mark, one at the 3/4 period mark, and one at the full period mark, where we say that the period is the amount of input or angle we have to go through before we start to repeat ourselves again. So one important thing really to remember here is that the period of our sine graph, here, let me get some of this stuff out of the way. The period of our sine graph and cosine graph is always going to be equivalent to 2 pi over b, where b is this value of the coefficient of x, and our amplitude is denoted by the absolute value of a, which is this a value out in front here. And so with that being said, basically what we're going to seek to do is construct this frame every single time that has a height of the amplitude. It goes above and below by the amplitude from the start of its frame, and then the length of the frame is equal to its period here, which is this 2 pi over b. So with respect to constructing this frame, what we want to know is this. Our sine curve and the cosine curve, we want to know their basic shapes inside of this frame. So our sine curve, remember, starts at its 0, goes to a maximum, then back to 0 halfway through the frame, down to its minimum, and then back to 0 again. This would be our sine curve, the basic sine curve, if and only if our a value is positive. And I know that the notes here have a capital A, but what we're really referring to is this a value out in front here. So if a is positive, then we have a sine graph that's not reflected and looks like this within its frame. If, however, it is reflected, we have a negative a value, we're just going to, instead of going to our maximum first with our sine curve, we're going to start at our 0 and then go to our minimum first, and then back to 0, and then to the maximum, and back to 0 again. And so we can see that really this is the same as my first sine curve over here on the left, but we reflect it over the x-axis. And then with our cosine curve, remember that cosine, as a matter of fact, starts at its maximum. So cosine will always start at a maximum at the beginning of its frame, then go to a 0, then go to its minimum, then go to a 0, and then back to its maximum again. But within the frame, you know, we make this little U-like curve here. It's just a piece of an entire cosine curve. But we would say that this is one cycle of the cosine curve right here. And then if we were to reflect this, instead of starting at the maximum value, our cosine graph would start at a minimum value, then go to 0, then go to its maximum, then go to 0, then go back to its minimum again. So a reflected cosine curve inside of the frame looks like this. And so with these basic shapes, really the whole idea is going to be, how can we construct the frame? So the good news is this. With respect to amplitude and with respect to period, we can just find those from the equation by using these bits of information. But where does our frame start? And this is why I've been referring to a starting point, the C over B comma D. Because in every one of these sketches, I'm going to go ahead and highlight these here. I know I colored over the top of them, but these yellow dots that you see right here, this is what we refer to as the starting point of the frame, the starting point of the frame. So what I want to be clear on is this, that the starting point of the frame does not necessarily mean your graph goes through the starting point. It did on these two right here. But with respect to cosine, the starting point of the frame really just told us where the frame starts, and then we use the amplitude to go up or down by that much and get the height of our frame, and we use the period length to get the length of our frame, and then we split it up into these partitions that we see here. So to put this all together, what we're going to do is we're going to look at the framing method for graphing here, and that would just be what you see right here, which would be this, starting by plotting the starting point and then constructing the frame from there, where we know the height of our frame is the amplitude of our graph and the length of our frame is the period of the graph. And then from there, what we're going to do is we're just going to sketch our 5 critical points that we can label inside the frame. So let's go ahead and take a look at this very first graph here. What we want to do is, first of all, identify the amplitude, period, and the starting point, and then construct our frame. And notice the instructions here say graph 2 cycles of the function. So what we'll do is we'll start by identifying some key values here. So with respect to our function y equals a sine bx minus c plus d. Not a bad idea. Let's go ahead and start by identifying a, b, c, and d. And so our a value here, our a value appears to be 3. And our b value, which is the coefficient of x inside of here, really we're just going to say is a 1. Our c value now, I notice that we're not going to add or subtract anything off of or onto this x inside parentheses, so we would say that its value is 0, and likewise we're not adding anything on here, so our d value is 0. So with respect to our amplitude, remember that the amplitude is always the absolute value of a, so our amplitude for this graph is going to be 3. The period of our sine and cosine graphs is 2 pi over b. In this case we have a b value of 1, so we say 2 pi over 1, this means the period of our graph is 2 pi. So now we have both the height and the length of our frame. The only thing we have left to find is where this frame should start, and what we always get is this c over b comma d coordinate. So in this particular instance, our c value is 0 and our b value is 1 and our d value is 0. So what this means is our frame is going to start at the point 0, 0. So let's go ahead and start by constructing our graph here. So I would say that with most trig functions we make the x-axis a little bit longer than the y-axis. Not always, but I would say it's helpful. And what we're going to do is we're going to start at our starting point. Now I notice the point 0, 0 is right here. And I'm not going to put a dot there, I'm just going to put a box there. We say our frame starts here. So with respect to how high our frame goes up and down above and below the starting point, we're going to say it's equal to the amplitude. In this case our amplitude is 3. So we are going to go up 3, 1, 2, 3, and we're going to go down 3, 1, 2, 3, and we should label these -3 and 3. So our frame, if we're going to sketch it in, is kind of like starting here. This is the left side of our frame right here. So now we want to get the length of our frame, and the length of our frame is always equal to the period length. So in this case, the period length is 2 pi. So we're starting at an x value of 0. If we were to add on 2 pi, I'm just going to go ahead and say that this is right here, this is 2 pi. Then we would have a frame now that goes all the way out to 2 pi from a height of 3 and from a height of -3. This would be our frame right here. So going from 0 to 2 pi. So to graph the rest of this, really where it says, okay, construct your frame and the starting point and then sketch your graph. What we're basically going to do is we're going to partition this frame up, and we split it down the middle in half, and then we split this halfway down the middle here. So with respect to this x value, it's always the average of the first and last. And with respect to average, that means just add them up and divide by however many there are. So 2 pi over 2 means that this x value here is pi. We should always label this. And then we're going to split these halves in half. And we can see clearly here that halfway between 0 and pi, this would be pi halves, and this would be 3 pi halves. So now that we've constructed our frame, the only thing we have left to do is to place our graph inside the frame. So you'll notice the next step in our process here just asks, is a negative? Because what we want to know is, would this graph be reflected with a positive a value? So with a positive a value, we say that this graph would not be reflected. And so what we're going to do is we're just going to graph all 5 critical points. And so those critical points, knowing that this is a sine curve, look back at our sine curve here. A non-reflected sine curve starts at 0, goes to its max and then 0 and then min and then 0. So all we're going to do is we're just going to place this graph into its frame. So we would say that starts at 0, goes to its maximum in the frame, back to 0 again, to its minimum in the frame, and then back to 0. So our sine curve in this case, we can see, if we look at the picture here, has a period of 2 pi and an amplitude of 3. So we wanted to graph 2 cycles of this. So how does one do this? Well, the key here is to just go out one more period length past this part here, 2 pi. So if we were to go 2 pi plus another 2 pi, we would say out to 4 pi, would look like this here. And all we have to do is really just extend our frame out to there. Splitting this in half and splitting these in half here, these x values on here, we would say that between 2 pi and 4 pi would be 3 pi. And this here would be, let's see, we'd have 5 pi halves to get out to here. And this would be 7 pi halves to get out to here. And all we would do is we would just rinse and repeat. We would really just kind of graph another repetition of our sine curve here. So what I want to do before we piece out this video is look at a couple other curves here, a cosine curve and another sine curve here. So let's start with our cosine. We look at our function here. It looks like we have an a value that is equal to 1, so our leading coefficient is 1. Our b value here looks like 2, and we have c and d of both 0. So with respect to amplitude, we have the absolute value of 1, which is 1. And then the period length, we have 2 pi over b, which in this case, we have 2 pi over 2, which means our period length is only going to be pi. And then lastly, our starting point here, c over b comma d, we say c is 0, over b is 2, comma d, which is 0. So in other words, our starting point is 0, 0. So to construct this graph, we're just going to start by constructing our frame here, which starts at 0, 0. So we say starting at 0, 0, we're going to go up and down by a height of 1. Essentially, that's the height of our frame here, 1 and negative 1. So we say here's the left side of our frame. So now we want to know how far out to go to the right, and according to this, the length of this would be pi. So I'm going to call this pi right here, and I'm going to say that our frame proceeds out to pi here. And so we need to split this in half down the middle, but also split this in half and then into fourths, always into fourths like this. So this middle number here, we say between 0 and pi, this would have to be pi halves, okay? And so this would have to be pi fourths, and this would be 3 pi fourths. So with respect to these here, we can go ahead and lay in our cosine graph. We have everything we need. Our cosine graph, remember, starts at its maximum and then goes to a 0 and then minimum, 0 and then maximum. So when we come back and look at this graph here, we say our cosine graph, really what we want to do first of all is assess whether or not it would be reflected. So since our a value is positive, we have a positive a value, it's not going to be reflected, then our cosine graph starts at a maximum, goes to its 0, goes to a minimum, goes to a 0, goes back to its maximum. So we would get a graph that just looks like this. And again, with repeating another cycle here, we go from pi out to 2 pi. We would just add on another part of our frame and split this up here and just say that it goes through another full cycle here if we wanted to graph 2 full cycles of this graph here. So looking at this last one here, you notice that we have a negative a value. And just to kind of come out and say it, what this is going to cause to happen to our graph is that we're going to end up with a reflection. So when we look at the amplitude, the interesting thing here is we say the absolute value of a is 2. So the amplitude is still certainly 2, but we have a reflected graph. And then the period, we say 2 pi over b, well the coefficient of x is 1. So we haven't changed the period of this graph, it's still 2 pi. And then with respect to starting point, we say c over b, so our b value here is 1, comma d, we still start at 0, 0. So we haven't translated anything yet. So sketching this picture here, I'm going to go ahead and make this longer again on the x-axis than the y-axis. We're going to start with the beginning of our frame, which starts at 0, 0. Our amplitude is 2, so we're going to go 2 above this, and we're going to go 2 below this to acquire the left side of our frame here. So now, with the period being 2 pi, I'm going to go ahead and go out 2 pi, we'll call this 2 pi, and this will represent the right side of our frame right there. So partitioning it in half and cutting this in half, halfway between 0 and 2 pi is pi. If we cut that in half, halfway between 0 and pi is pi halves. And halfway between pi and 2 pi is 3 pi divided by 2, or 3 pi halves. And so to sketch this graph with a reflected sine curve, remember sine starts at 0, goes max 0, min 0. Instead it's going to start by going down to its minimum and then proceed to its maximum. So we would get a graph that, because it's sine, starts at 0, but then goes down to its minimum first, and then 0, and then maximum, and then 0. And again, to extend this out to 4 pi, all we would need to do is just extend this another period length, cut this in half, cut this in half, cut this in half, and just keep running with it here. We could get 2 cycles of our graph pretty easily. But here's our reflected sine curve that has an amplitude of 2 and a period length of 2 pi. Cheers.